Warmly welcome all of you in this class of 11. Okay. Are you ready for learning? Yeah. Today in this class, I am going to discuss for you a very important topic, that is error. Do you know error is always presented any type of measurement? Without errors, no measurement can be possible. We can't remove completely errors for the measurement, but we minimize it. Okay? Errors has many types like personal error, random error, list count error, gross error, etc. The error which is originated from the individual basis is called personal error, and the error which is originated due to the defect of some instrumental problems is called instrumental errors. Okay, like that. These are the explained in your book. I am here going to explain another classification of errors. Look here. Types of errors. These classification of errors based on the mathematical approaches. Okay? In this case, error has three types: absolute errors, relative errors, percentage error. Okay? How many types of errors? Three types, which is based on the mathematical approaches. Okay? Absolute errors, relative errors, and percentage error. Here we discuss absolute error. Look here on the board. What is absolute error? The magnitude of the difference between the true value of quantity measured and individual measured value is called absolute error. Again we repeat. The magnitude of the difference between the true value of quantity measured and individual measured value is called absolute errors. Okay. Here, question arises: how we find absolute errors? We can explain it for an example. Okay? Suppose I am giving you a rod and tell to measure the length of the rod individually, all of you. Okay? Suppose the number you are present here is n, and you measured the values, the length of the rod, like let A1, A2, A3, A4 dash dash AN be the measured value, measured value of the given measurement, given rod. Okay, first of all we obtain its average value. That implies mean value of the measurement. Okay, mean, that means average. A1 plus A2 plus A3 dash dash AN upon N. That means total sum upon total number. Okay, it is represented as a mean. Okay, therefore it is written as A1 plus A2 plus A3 dash dash AN upon N. If these are in numbers, then sum result is come. Okay, and we assume that if delta A1, delta A2, delta A3 be the absolute errors in the given measurement of the rod. Okay, if delta A1, this is the symbol of delta, it is the capital form, it is a Greek letter. Delta A1, delta A2, delta A3, delta A3, delta AN be the absolute errors, be the absolute errors respectively. Okay, this indicates that in measured value A1 some error is presented and it is denoted by delta A1, like that delta A2, delta A3, okay, and delta N. Now delta A1 is equal to A mean minus A1. That means first of all told to you, error can be minimized, never can be removed. Okay? Delta A1 is equal to A min minus A1. Delta A2 is equal to A min minus A2. Delta A3 is equal to A min minus A3. Okay? And that implies delta n is equal to A min minus A n. Okay. That means each individual measurement has some errors which can be obtained by the difference of its true measurements. That means mean value, arithmetic mean value of the measurements minus individual measurement. Okay? Now, I am going to explain its mean absolute error. Mean absolute error. Mean absolute errors. Okay? Here some result is obtained and the arithmetic mean of all absolute errors is known as mean absolute error, and it is represented as delta A mean is equal to delta A1 plus delta A2 plus delta A3 plus delta AN upon N. Here mod indicates that we always take positive value of absolute errors. We can't take its negative value. Okay? And after doing some mathematical operations, some result is come which is called mean absolute error. Okay?